Alright, so in this example problem we're going to explore magnetic flux. So we have a square surface of side 2 centimeter by 2 centimeter. So I've drawn that here, and it's orientated in the xy plane. So I've drawn this is y, this is x. And our origin, this is actually at z, so z equals 0, so we're literally in the xy plane. And we want to know what is the magnetic flux through the surface due to a uniform magnetic field, and we're given a component. So our x component is 0.1 Tesla, our y component is 0.3 Tesla, and our z component is 0.5 Tesla. Alright, so we want to know what the magnetic flux is. So we're going to do B dot A, and we don't have to worry about integrating in terms of A because it's a uniform magnetic field. So we can do our dot product here. And so I'm using the form of the dot product here where we take the components times each other and add. So the n hat direction in this case, so the direction that the area points is going to be in the z hat direction because our surface here is orientated in the xy plane. So when I do my dot product here, a of x is 0, a of y is 0, so I don't have to worry about these first terms. I have to worry about the last one. So I'm going to take the x component, or the z component of the magnetic field times the z component of the area, which is the entire area essentially. So I'm going to take 0.5 Teslas, and I converted my 2 centimeters into meters, so 0.02 meters times 0.02 meters, and it gives me a magnetic flux of 2 times 10⁻⁴ Webers.